एवरीवन, वंस अगेन वेलकम बैक टू आवर चैनल बीट द नीट। सो बच्चों, आप लोगों ने जैसे सजेशन दिए मुझे केमिस्ट्री ऑडियो बुक क्लास 11 के लिए, मैंने उसी के अकॉर्डिंग आपके लिए ऑडियो बुक रिकॉर्ड कर रही हूँ। आज मैं स्टार्ट करने जा रही हूँ यूनिट 14। आई नो ये लास्ट में है चैप्टर, बट इसकी रिक्वायरमेंट आप लोगों को ज्यादा है। तो बेसिकली मेरा मकसद यही है कि मैं आप लोगों की ज्यादा से ज्यादा प्रिपरेशन में हेल्प कर सकूं ताकि आप जल्द से जल्द सेलेक्ट हो सके नीट एग्जाम में। सो इसलिए मैं यूनिट 14 एनवायरमेंटल केमिस्ट्री स्टार्ट करने जा रही हूं। The world has achieved brilliance without wisdom, power without conscience. Ours is a world of nuclear giants and ethical infants. You have already studied about environment in your earlier classes. Environmental studies deal with the sum of all social, economical, biological, physical, and chemical interrelations with our surroundings. In this unit, the focus will be on environmental chemistry. Environmental chemistry deals with the study of the origin, transport, reactions, effects, and fates of chemical species in the environment. Let us discuss some important aspects of environmental chemistry. 14.1 Environmental pollution. Environmental pollution is the effect of undesirable changes in our surrounding that have harmful effects on plants, animals, and human beings. A substance which causes pollution is known as pollutant. Pollutants can be solid, liquid, or gaseous substance present in greater concentration than in natural abundance and are produced due to human activities or due to natural happenings. Do you know? An average human being requires nearly 12 to 15 times more air than food. So even small amounts of pollutants in the air become significant compared to similar level present in the food. Pollutants can be degradable like discarded vegetables which rapidly break down by natural processes. On the other hand, pollutants which are slowly degradable remain in the environment in an unchanged form for many decades. For example, substances such as dichloro-diphenyl trichloroethane, that is DDT, plastic materials, heavy metals, many chemicals, nuclear waste, etc. once released into the environment are difficult to remove. These pollutants cannot be degraded by natural process and are harmful to living organisms. In the process of environmental pollution, pollutants originate from a source and get transported by air or water or dumped into the soil by human beings. 14.2 Atmospheric pollution. The atmosphere that surrounds the earth is not of the same thickness at all heights. There are concentric layers of air or regions and each layer has different density. The lowest region of atmosphere in which the human beings along with their other organisms live is called Trophospheric. It extends up to the height of 10 km approximately from sea level. Above the troposphere, between 10 and 50 km above sea level, lies stratosphere. Troposphere is a turbulent, dusty zone containing air, much water vapor, and clouds. This is a region of strong air movement and cloud formation. The stratosphere, on the other hand, contains dinitrogen, dioxygen, ozone, and little water vapor. Atmospheric pollution is generally studied as trophospheric and stratospheric pollution. The presence of ozone in the stratosphere prevents about 99.5% of the sun's harmful ultraviolet radiations from reaching the Earth's surface and thereby protecting humans and other animals from its effect. 14.2.1 Trophospheric pollution. Trophospheric pollution occurs due to the presence of undesirable solid or gaseous particles in the air. The following are the major gaseous and particulate pollutants present in the troposphere. Number 1. Gaseous air pollutants. These are oxides of sulfur, nitrogen and carbon, hydrogen sulfide, hydrocarbons, ozone and other oxidants. Number 2. Particulate pollutants. These are dust, mist, fumes, smoke, smog, etc. Number 1. Gaseous air pollutants. A. Oxides of sulfur. Oxides of sulfur are produced when sulfur-containing fossil fuel is burnt. The most common species is sulfur dioxide is a gas that is poisonous to both animals and plants. It has been reported that even a low concentration of sulfur dioxide causes respiratory diseases, example asthma, bronchitis, emphysema in human beings. Sulfur dioxide causes irritation to the eyes, resulting in tears and redness. High concentration of SO2 leads to stiffness of flower buds, which eventually fall off from plants. Uncatalyzed oxidation of sulfur dioxide is slow. However, the presence of particulate matter in polluted air catalyzes the oxidation of sulfur dioxide to sulfur trioxide. 2SO2 plus O2 gives out 2SO3. The reaction can also be promoted by ozone and hydrogen peroxide, that is SO2 plus O3 gives out SO3 plus O2. SO2 plus H2O2 gives out H2SO4. B. Oxides of nitrogen. Dinitrogen and dioxygen are the main constituents of air. These gases do not react with each other at a normal temperature. At high altitudes, when lightning strikes, they combine to form oxides of nitrogen. NO2 is oxidized to nitrate ion, NO3 negative, which is washed into the oil, where it serves as a fertilizer. In an automobile engine, at high temperature, when fossil fuel is burned, dinitrogen and dioxygen combine to yield significant quantities of nitric oxide, that is NO, and nitrogen dioxide, that is NO2, as given below. N2 plus O2 gives out 2NO at 1483 Kelvin. NO reacts instantly with oxygen to give NO2, that is 2NO plus O2 gives out 2NO2. Rate of production of NO2 is faster when the nitric oxide reacts with ozone in the stratosphere. NO plus O3 gives out NO2 plus O2. The irritant red haze in the traffic and congested places is due to oxides of nitrogen. Higher concentration of NO2 damage the leaves of plants and retard the rate of photosynthesis. Nitrogen dioxide is a lung irritant that can lead to an acute respiratory disease in children. It is toxic to living tissues also. Nitrogen dioxide is also harmful to various textile fibers and metals. C. Hydrocarbons. Hydrocarbons are composed of hydrogen and carbon only and are formed by incomplete combustion of fuel used in automobiles. Hydrocarbons are the carcinogenic, that is, they cause cancer. They harm plants by causing aging, breakdown of tissues, and shedding of leaves, flowers, and twigs. D. Oxides of carbon. Number 1. Carbon monoxide. Carbon monoxide is one of the most serious air pollutant. It is colorless and odorless gas, highly poisonous to living beings because of its ability to block the delivery of oxygen to the organs and tissues. It is produced as a result of incomplete combustion of carbon. Carbon monoxide is mainly released into the air by automobile exhaust. Other sources which produce CO involve incomplete combustion of coal, firewood, petrol, etc. The number of vehicles has been increasing over the years all over the world. Many vehicles are poorly maintained and several have inadequate pollution control equipments, resulting in the release of greater amount of carbon dioxide and other polluting gases. Do you know why carbon monoxide is poisonous? It binds to hemoglobin to form carboxyhemoglobin, which is about 300 times more stable than the oxygen hemoglobin complex. In blood, when the concentration of carboxyhemoglobin reaches about 3 to 4%, the oxygen carrying capacity of blood is greatly reduced. This oxygen deficiency results into headache, weak eyesight, nervousness, and cardiovascular disorder. This is the reason why people are advised not to smoke. In pregnant women who have the habit of smoking, the increased CO level in blood may induce premature birth, spontaneous abortions, and deformed babies. Number 2. Carbon dioxide. Carbon dioxide is released into the atmosphere by respiration, burning of fossil fuels for energy, and by decomposition of limestone during the manufacture of cement. It is also emitted during volcanic eruptions. Carbon dioxide gas is confined to troposphere only. Normally, it forms about 0.03% of volume of the atmosphere. With the increased use of fossil fuels, a large amount of carbon dioxide gets released into the atmosphere. Excess of CO2 in the air is removed by green plants, and this maintains an appropriate level of CO2 in the atmosphere. Green plants require CO2 for photosynthesis and they in turn emit oxygen, thus maintaining the delicate balance. As you know, deforestation and burning of fossil fuel increases the CO2 level and disturb the balance in the atmosphere. The increased amount of CO2 in the air is mainly responsible for global warming. Global warming and greenhouse effect, about 75% of the solar energy reaching the earth is absorbed by the earth's surface, which increases its temperature. The rest of the heat radiates back to the atmosphere. Some of the heat is trapped by gases such as carbon dioxide, methane, ozone, chlorofluorocarbon compounds, that is CFCs, and water vapor in the atmosphere. Thus, they add to the heating of the atmosphere. This causes global warming. We all know that in cold places, flower, vegetables, and fruits are grown in glasses covered areas called greenhouse. Do you know that we humans also live in a greenhouse? Of course, we are not surrounded by glass but a blanket of air called the atmosphere, which has kept the temperature on Earth constant for centuries. But it is now undergoing change, though slowly. Just as the glass in a greenhouse holds the sun's warmth inside, atmosphere traps the sun's heat near the Earth's surface and keep it warm. This is called natural greenhouse effect because it maintains the temperature and makes the Earth perfect for life. In a greenhouse, solar radiations pass through the transparent glass and heat up the soil and the plants. The warm soil and plants emit infrared radiations. Since glass is opaque to infrared radiation, thermal region it partially reflects and partially absorbs these radiations. This mechanism keeps the energy of the sun trapped in the greenhouse. Similarly, carbon dioxide molecules also trap heat as they are transparent to sunlight, but not to the heat radiation if the amount of carbon dioxide crosses the delicate proportion of 0.03%. The natural greenhouse balance may get disturbed. Carbon dioxide is a major contributor to global warming. Besides carbon dioxide, other greenhouse gases are methane, water vapor, nitrous oxide, CFCs, and ozone. Methane is produced naturally when vegetation is burned, digested, or rotted in the absence of oxygen. Large amounts of methane are released in paddy fields, coal mines, from rotting garbage dumps, and by fossil fuels. Chlorofluorocarbons are man-made industrial chemicals used in air conditioning, etc. CFCs are also damaging the ozone layer. Nitrous oxide occurs naturally in the environment. In recent years, their quantities have increased significantly due to the use of chemical fertilizer and the burning of fossil fuels. If these trends continue, the average global temperature will increase to a level which may lead to melting of polar ice caps and flooding of low-lying areas all over the earth. Increase in the global temperature increases the incidence of infectious diseases like dengue, malaria, yellow fever, sleeping sickness, etc. Think it over. What can we do to reduce the rate of global warming? If burning of fossil fuels, cutting down forests, trees add to greenhouse gases in the atmosphere, we must find ways to use these just efficiently and judiciously. One of the simple things which we can do to reduce global warming is to minimize the use of automobiles. Depending upon the situation, one can use bicycle, public transport system, or go for carpool. We should plant more trees to increase the green cover, avoid burning of dry leaves, wood, etc. It is illegal to smoke in public places and workplaces because it is harmful not only for the one who is smoking but also for others, and therefore we should avoid it. Many people do not understand the greenhouse effect and the global warming. We can help them by sharing the information that we have. Acid rain. We are aware that normally rainwater has a pH of 5.6 due to the presence of H ion formed by the reaction of rainwater with carbon dioxide present in the atmosphere. H2O plus CO2 gives out H2CO3. H2CO3, that is a reversible equation, gives out H ion plus HCO3 ion. When the pH of the rainwater drops below 5.6, it is called acid rain. Acid rain refers to the ways in which acid from the atmosphere is deposited on the Earth's surface. Oxides of nitrogen and sulfur, which are acidic in nature, can be blown by wind along with solid particles in the atmosphere and finally settle down either on the ground as dry deposition or in water, fog, and snow as wet deposition. Figure 14.1. This is Figure 14.1, acid deposition. You can see this diagram. Acid rain is a byproduct of a variety of human activities that emit the oxides of sulfur and nitrogen in the atmosphere. As mentioned earlier, burning of fossil fuels, which contain sulfur and nitrogenous matter, such as coal and oil in power station and furnaces, or petrol and diesel in motor engines, produce sulfur dioxide and nitrogen oxides. SO2 and NO2 after oxidation and reaction with water are major contributors to acid rain, because polluted air usually contains particulate matter that catalyze the oxidation. 2SO2 plus O2 plus 2H2O gives out 2H2SO4, 4NO2 plus O2 plus 2H2O gives out 4HNO3. Ammonium salts are also formed and can be seen as an atmospheric haze, that is aerosol of fine particles. Aerosol particles of oxides or ammonium salts in raindrop result in wet deposition. SO2 is also absorbed directly on both solid and liquid ground surfaces and is thus deposited as dry deposition. Acid rain is harmful for agriculture, trees, plants, and it dissolves and washes away nutrients needed for their growth. It causes respiratory ailments in human beings and animals. When acid rain falls and flows as groundwater to reach rivers, lakes, etc., it affects plants and animals' life in aquatic ecosystem. It corrodes water pipes, resulting in the leaching of heavy metals such as iron, lead, and copper into the drinking water. Acid rain damages buildings and other structures made of stone or metal. The Taj Mahal in India has been affected by acid rain. Activity 1. You can collect sample of water from nearby places and record their pH values. Discuss your result in the class. Let us discuss how we can help to reduce the formation of acid rain. This can be done by reducing the emission of sulfur dioxide and nitrogen dioxide in the atmosphere. We should use less vehicle driven by fossil fuels, use less sulfur content fossil fuels for power plants and industries. We should use natural gas, which is better fuel than coal, or use coal with less sulfur content. Catalytic converters must be used in cars to reduce the effect of exhaust fumes on the atmosphere. The main component of the converter is a ceramic honeycomb coated with precious metals PD, PT, and RH. The exhaust gases containing unburned fuel CO and NOx, when passed through the converter at 573 Kelvin, are converted into CO2 and N2. We can also reduce the acidity of the soil by adding powdered limestone to neutralize the acidity of the soil. Many people do not know of acid rain and its harmful effects. We can make them aware by passing on this information and save the nature. Taj Mahal and acid rain. The air around the city of Agra, where the Taj Mahal is located, contains fairly high levels of sulfur and nitrogen oxides. It is mainly due to a large number of industries and power plants around the area. Use of poor quality of coal, kerosene, and firewood as a fuel for domestic purposes add up this problem. The resulting acid rain reacts with marble, CaCO3 of Taj Mahal, that is CaCO3 plus H2SO4, gives out CaSO4 plus H2O plus CO2, causing damage to this wonderful monument that has attracted people from around the earth, around the world. As a result, the monument is being slowly disfigured and the marble is getting discolored and lusterless. The government of India announced an action plan in early 1995 to prevent the disfiguring of this historical monument. Mathura refinery has been already taken suitable measures to check the emission of toxic gases. This plan aims at clearing the air in Taj Mahal Trapezium, an area that includes the towns of Agra, Firozabad, Mathura, and Bharatpur. Under this plan, more than 2,000 polluting industries lying inside the trapezium would switch over to the use of natural gases or liquefied petroleum gas instead of coal or oil. A new natural gas pipeline would bring more than 500,000 cubic meters of natural gas a day to this area. People living in the city will also be encouraged to use liquefied petroleum gas in place of coal, kerosene, or firewood. Vehicles plying on highways in the vicinity of the Taj would be encouraged to use low sulfur content diesel. Number 2. Particulate pollutants. Particulate pollutants are the minute solid particles or liquid droplets in air. These are present in vehicle emissions, smoke particles from fires, dust particles, and ash from industries. Particulates in the atmosphere may be viable or non-viable. The viable particulates, example bacteria, fungi, molds, algae, etc., are minute living organisms that are dispersed in the atmosphere. Human beings are allergic to some of the fungi found in air. They can also cause plant diseases. Non-viable particulates may be classified according to their nature and size as follows. A. Smoke particulates consist of solid or mixture of solid and liquid particles formed during combustion of organic matter. Examples are cigarette smoke, smoke from burning of fossil fuel, garbage and dry leaves, oil smoke, etc. B. Dust is composed of fine solid particles over 1 micrometer in diameter produced during crushing, grinding and attribution of solid materials. Sand from sandblasting, sawdust from wood works and pulverized coal, cement and fly ash from factories, dust storms, etc. are some typical examples of this type of particulate emission. C. Mist are produced by particles of spray liquids and by condensation of vapors in air. Examples are sulfuric acid mist and herbicides and insecticides that miss their targets and travel through air and form mist. D. Fumes are generally obtained by the condensation of vapors during sublimation, distillation, boiling, and several other chemical reactions. Generally, organic solvents, metals, and metallic oxides form fume particles. The effect of particulate pollutants are largely dependent on the particle size. Airborne particles such as dust, fumes, mist, etc. are dangerous for human health. Particulate pollutants bigger than 5 microns are likely to lodge in the nasal passage, whereas particles of about 10 micron enter into lungs easily. Lead used to be major air pollutant emitted by vehicles. Leaded petrol used to be the primary source of airborne lead emission in Indian cities. This problem was now being overcome by using unleaded petrol in most of the cities in India. Lead interferes with the development and maturation of red blood cells. Smog. The word smog is derived from smoke and fog. This is the most common example of air pollution that occurs in many cities throughout the world. There are two types of smog. Number 1 or A. Classical smog occurs in cool humid climate. It is a mixture of smog, fog and sulfur dioxide. Chemically it is a reducing mixture and so it is also called as reducing smog. B. Photochemical smog occurs in warm, dry and sunny climate. The main components of photochemical smog results from the action of sunlight on unsaturated hydrocarbons and nitrogen oxides produced by automobiles and factories. Photochemical smog has high concentration of oxidizing agents, is therefore called as oxidizing smog. Formation of photochemical smog: when fossil fuels are burned, a variety of pollutants are emitted into the Earth's troposphere. Two of the pollutants that are emitted are hydrocarbons, unburned fuels, and nitric oxides. When these pollutants build up to sufficiently high levels, a chain reaction occurs from their interaction with sunlight in which NO is converted into the nitrogen oxide. This NO2 in turn absorbs energy from sunlight and breaks up into the nitrogen oxide and free oxygen atom. Figure 14.2 I will show you. NO2 in presence of light gives out, in presence of sunlight, gives out NO plus O. Oxygen atoms are very reactive and combine with O2 in air to produce ozone. O plus O2 gives out O3. The ozone formed in the above reaction rapidly react with NO formed in the reaction to regenerate NO2. NO2 is a brown gas and at sufficiently high levels can contribute to haze. NO plus O3 gives out NO2 plus O2. Ozone is a toxic gas and both NO2 and O3 are a strong oxidizing agent and can react with the unburned hydrocarbons in the polluted air to produce chemicals such as formaldehyde, acrolein and peroxyacetyl nitrate, that is PAN. 3CH4 plus 2O3 gives out 3CH2 double bond O plus 3H2O. And acrolein formula you can see, and peroxyacetyl nitrate PAN formula also you can see. Effects of photochemical smog. The common components of photochemical smog are ozone, nitric oxide, acrolein, formaldehyde, and peroxyacetyl nitrate, that is PAN. Photochemical smog causes serious health problems. Both ozone and PAN act as powerful eye irritants. Ozone and nitric oxide irritate the nose and throat, and their high concentration causes headache, chest pain, dryness of the throat, cough, and difficulty in breathing. Photochemical smog leads to cracking of rubber and extensive damage to plant life. It also causes corrosion of metals, stones, building materials, rubber and painted surface. See the diagram 14.2, that is photochemical smog occurs where sunlight acts on vehicle pollutants. How can photochemical smog be controlled? Many techniques are used to control or reduce the formation of photochemical smog. If we control the primary precursor of photochemical smog such as NO2 and hydrocarbons, the secondary precursors such as ozone and PAN, the photochemical smog will automatically be reduced. Usually catalytic converters are used in the automobiles which prevent the release of nitrogen oxide and hydrocarbons to the atmosphere. Certain plants, example Pinus, Juniperus, Quercus, Pyrus and Vitis can metabolize nitrogen oxide and therefore their plantation could help in this matter. Stratospheric pollutant formation and breakdown of ozone. The upper stratosphere consists of considerable amount of ozone which protect us from the harmful ultraviolet radiations, that is lambda 255 nm, coming from the sun. These radiations cause skin cancer, melanoma in humans. Therefore, it is important to maintain the ozone shield. Ozone in the stratosphere is a product of UV radiations acting on dioxygen molecules. The UV radiation split apart molecular oxygen into free oxygen atoms. These oxygen atoms combines with the molecular oxygen to form ozone. O2 gives out O plus O, that is nascent oxygen in the presence of ultraviolet radiation, and when nascent oxygen combines with the O2, it forms O3, that is a reversible reaction. Ozone is thermodynamically unstable and decomposes to molecular oxygen. Thus, a dynamic equilibrium exists between the production and decomposition of ozone molecules. In recent years, there have been reports of the depletion of this protective zone layer because of the presence of certain chemicals in the stratosphere. The main reason of ozone layer depletion is believed to be the release of chlorofluorocarbon compounds, also known as freons. These compounds are non-reactive, non-flammable, non-toxic organic molecules and therefore used in refrigerator, air conditioners, in the production of plastic foam and by the electronic industry for cleaning computer parts, etc. Once CFCs are released in the atmosphere, they mix with the normal atmospheric gases and eventually reach the stratosphere. In stratosphere, they get broken down by powerful UV radiations, releasing chlorine-free radical. CF2Cl2 in presence of UV light gives out chloride free radical plus CF2Cl free radical. The chlorine radical then react with the stratospheric ozone to form chlorine monoxide radicals and molecular oxygen, that is Cl plus O3 gives out ClO plus O2. Reaction of chlorine monoxide radical with atomic oxygen produces more chlorine radicals, that is ClO radical plus O gives out chloride radical plus O2. The chlorine radicals are continuously, that was the chlorine radical. The chlorine radicals are continuously regenerated and cause the breakdown of ozone. The CFCs are transporting agents for continuously generating chlorine radicals into the stratosphere and damaging the ozone layer. The ozone hole. In 1980s, atmospheric scientists working in Antarctica reported about depletion of ozone layer, commonly known as ozone hole, over the South Pole. It was found that a unique set of conditions was responsible for the ozone hole. In summer season, nitrogen dioxide and methane react with chlorine monoxide and chlorine atoms, forming chlorine sinks, preventing much ozone depletion, whereas in winter a special type of clouds called polar stratospheric clouds are formed over Antarctica. These polar stratospheric clouds provide surface on which chlorine nitrate formed gets hydrolyzed to form hypochlorous acid. It also reacts with hydrogen chloride produced as per reaction to give molecular chlorine. ClO plus NO2 gives out ClONO2. Cl plus CH4 gives out CH3 plus HCl. ClONO2 plus H2O gives out HOCl plus HNO3. And ClONO2 plus HCl gives out Cl2 plus HNO3. When sunlight returns to the Antarctica in the spring, the sun's warmth breaks up the clouds and HOCl and Cl2 are photolyzed by sunlight as given in reactions. HOCl gives out OH free radical plus chloride, chlorine free radical. Cl2 in the presence of sunlight gives out 2Cl free radical. The chlorine radicals thus formed initiate the chain reaction for ozone depletion as described earlier. Effects of depletion of the ozone layer. With the depletion of ozone layer, more UV radiation filters into troposphere. UV radiation lead to aging of skin, cataract, sunburn, skin cancer, killing of many phytoplankton, damage to fish productivity, etc. It has also been reported that plant protein gets easily affected by UV radiations, which leads to the harmful mutation of cells. It also increases evaporation of surface water through the stomata of the leaves and decreases the moisture content of the soil. Increase in UV radiation damages paints and fibers, causing them to fade faster. 14.3 Water pollution. Water is essential for life. Without water, there would be no life. We usually take water as granted for its purity, but we must ensure the quality of water. Pollution of water originates from human activities. Through different paths, pollution reaches surface or groundwater. Easily identified source or place of pollution is called as point source. Example, municipal and industrial discharge pipes, where pollutants enter the water source. Non-point sources of pollution are those where a source of pollution cannot be easily identified. Example, agricultural runoff from farm animals and croplands, acid rain, storm water drainage from street parking lots and lawns, etc. Table 14.1 list of the major water pollutants and their sources. Let me show you the table. Microorganism, these are the pollutant and source I am telling you. Microorganisms, domestic sewage, organic waste, domestic sewage, animal excreta and waste, decaying animals and plants, discharge from food processing factories, plant nutrients, chemical fertilizers, toxic heavy metals, industries and chemical factories, sediments, erosion of soil by agriculture and strip mining, pesticides, chemicals used for killing insects, fungi and weeds, radioactive substances, mining of uranium containing minerals, heat, water used for cooling in industry. 14.3.1 Causes of water pollution. Number 1. Pathogens. The most serious water pollutants are the disease-causing agents called pathogens. Pathogens include bacteria and other organisms that enter water from domestic sewage and animal excreta. Human excreta contain bacteria such as E. coli and Streptococcus faecalis, which cause gastrointestinal diseases. Number 2. Organic waste. The other major water pollutant is organic matter such as leaves, grass, trash, etc. They pollute water as a consequence of runoff. Excessive phytoplankton growth within water is also cause of water pollution. These wastes are biodegradable. A large population of bacteria decomposes organic matter present in water. They consume oxygen dissolved in water. The amount of oxygen that water can hold in the solution is limited. In cold water, dissolved oxygen can reach a concentration up to 10 ppm, that is parts per million, whereas oxygen in air is about 200,000 ppm. That is why even a moderate amount of organic matter, when decomposes in water, can deplete the water of its dissolved oxygen. The concentration of dissolved oxygen in water is very important for aquatic life. If the concentration of dissolved oxygen of water is below 6 ppm, the growth of fish gets inhibited. Oxygen reaches water either through atmosphere or from the process of photosynthesis carried out by many aquatic green plants during daylight. However, during night, photosynthesis stops, but the plants continue to respire, resulting in reduction of dissolved oxygen. The dissolved oxygen is also used by microorganisms to oxidize organic matter. If too much of organic matter is added to water, all the available oxygen is used up. This causes oxygen-dependent aquatic life to die. Thus, anaerobic bacteria which do not require oxygen begin to break down the organic waste and produce chemicals that have a foul smells and are harmful to human health. Aerobic bacteria degrade these organic waste and keep the water depleted in dissolved oxygen. Thus, the amount of oxygen required by bacteria to break down the organic matter present in certain volume of a sample water is called biochemical oxygen demand, that is BOD. The amount of BOD in the wastewater is measure of the amount of organic material in the water in terms of how much oxygen will be required to break it down biologically. Clean water would have BOD value of less than 5 ppm, whereas highly polluted water could have BOD value of 17 ppm or more. Number third, chemical pollutants. As we know that water is an excellent solvent, water soluble in organic chemicals that includes heavy metals such as cadmium, mercury, nickel, etc. constitute an important class of pollutants. All these metals are dangerous to humans because our body cannot excrete them. Over the time, it crosses the tolerance limit. These metals then can damage kidneys, central nervous system, liver, etc. Acids like sulfuric acids from mine drainage and salts from many different sources including raw salt used to melt snow and ice in the colder climates. That is, sodium and calcium chloride are water-soluble chemical pollutants. The organic chemical are another group of substances that are found in polluted water. Petroleum products pollute many sources of water, example major oil spills in ocean. Other organic substances with serious impacts are the pesticides that drift down from sprays or runoff from lands. Various industrial chemicals like polychlorinated biphenyls (PCBs), which are used as cleansing solvent, detergents, and fertilizers, add to the list of a water pollutant. PCBs are suspected to be carcinogenic. Nowadays, most of the detergents available are biodegradable. However, their use can create other problems. The bacteria responsible for degrading biodegradable detergent feed on it and grow rapidly. While growing, they may use up all the oxygen dissolved in water. The lack of oxygen kills all the other forms of aquatic life such as fish and plants. Fertilizers contain phosphate as additives. The addition of phosphates in water enhances algae growth. Such profuse growth of algae covers the water surface and reduces the oxygen concentration in water. This leads to an anaerobic condition, commonly with accumulation of obnoxious decay and animal death. Thus, bloom-infested water inhibits the growth of other living organisms in the water body. This process in which nutrient-enriched water bodies support a dense plant population which kills animal life by depriving it of oxygen and results in subsequent loss of biodiversity is known as eutrophication. 14.3.2 International Standards for Drinking Water. The international standards for drinking water are given below and they must be followed. Fluoride. For drinking purposes, water should be tested for fluoride ion concentration. Its deficiency in drinking water is harmful to man and causes disease such as tooth decay, etc. Soluble fluoride is often added to drinking water to bring its concentration up to 1 ppm. The fluoride ions make the enamel on the teeth much harder by converting hydroxyapatite, that is the 3Ca3 whole PO4 whole twice into CaOH whole twice. The enamel on the surface of the teeth into much harder fluoroapatite, that is 3Ca3PO4 whole twice into CaF2. However, fluoride ion concentration above 2 ppm causes brown mottling of teeth. At the same time, excess fluoride over 10 ppm causes harmful effect to bones and teeth, as reported from some parts of Rajasthan. Lead. Drinking water gets contaminated with lead when lead pipes are used for transportation of water. The prescribed upper limit concentration of lead in drinking water is about 50 ppb. Lead can damage kidney, liver, reproductive system, etc. Sulfate. Excessive sulfate, that is more than 500 ppm in drinking water, causes laxative effect. Otherwise, at moderate level, it is harmless. Nitrate. The maximum limit of nitrate in drinking water is 50 ppm. Excess nitrate in drinking water can cause disease such as methemoglobinemia, that is blue baby syndrome. Other metals. The maximum concentration of some metals recommended in drinking water as given in table 14.2. Here you can see the maximum prescribed concentration of some metals in drinking water. Fe 0.2, Mn 0.05, aluminium 0.2, Cu 3, zinc 5, cadmium 0.005. 14.4 Soil pollution. India, being an agriculture-based economy, gives high priority to agriculture, fisheries, and livestock development. The surplus production is stored by governmental and non-governmental organizations for the lean season. The food loss during the storage also needs special attention. Have you ever seen the damages causes to the crops, food items by insects, rodents, wheat, and crop diseases, etc.? How can we protect them? You are acquainted with some insecticides and pesticides for protection of our crop. However, these insecticides, pesticides and herbicides cause soil pollution. Hence, there is a need for their judicious use. 14.4.1 Pesticides. Prior to World War II, many naturally occurring chemicals such as nicotine by planting tobacco plants in the crop field were used as pest controlling substances for major crops in agriculture practices. During World War II, DDT was found to be the great use in the control of malaria and other insect-borne diseases. Therefore, after the war, DDT was put to use in agriculture to control the damages caused by insects, rodents, weeds, and various crop diseases. However, due to adverse effects, its use has been banned in India. Pesticides are basically synthetic toxic chemicals with ecological repercussion. The repeated use of the same or similar pesticides give rise to pests that are resistant to that of group of pesticides, thus making the pesticides ineffective. Therefore, as insect resistance of DDT increased, other organic toxins such as eldrin and dieldrin were introduced in the market by pesticide industry. Most of the organic toxins are water insoluble and non-biodegradable. These high persistent toxins are therefore transferred from lower trophic level to higher trophic level through food chain. Over the time, the concentration of toxin in higher animals reach a level which causes serious metabolic and physiological disorder. See the figure 14.3. At each trophic level, the pollutant gets 10 times concentrated. In response to high persistence of chlorinated organic toxin, a new series of less persistent or more biodegradable products called organophosphates and carbamates have been introduced in the market. But these chemicals are severe nerve toxins and hence more harmful to humans. As a result, there are reports of some pesticides-related deaths of agriculture field workers. Insects have become resistant to these insecticides also. The insecticide industry is engaged in developing new group of insecticide, but one has to think there's this only situation to pest menace. These days, the pesticide industry has shifted its attention to herbicides such as sodium chlorate, NaClO3, sodium arsenite, Na3SaSO3, and many others. During the first half of the last century, the shift from mechanical to chemical weed control had provided the industry with flourishing economic market. But one must remember that these are also not environment friendly. Most herbicides are toxic to mammals but are not as persistent as organochlorides. These chemicals decompose in a few months, like organochlorides. These two become concentrated in the food web. Some herbicides cause birth defects. Studies show that cornfields sprayed with herbicides are more prone to insect attack and plant disease than fields that are weeded manually. Pesticides and herbicides represent only a very small portion of widespread chemical pollution. A large number of other compounds that are used regularly in chemicals and industry process for manufacturing activities are finally released in the atmosphere in one or other form. 14.5 Industrial waste. Industrial solid waste are also sorted out as biodegradable and non-biodegradable waste. Biodegradable waste are generated by cotton mills, food processing units, paper mills, and textile factories. Non-biodegradable waste are generated by thermal power plant, which produce fly ash, integrated iron, and steel plants which produce blast furnace slag and steel melting slag. Industries manufacturing aluminium, zinc, and copper produce mud and tailings. Fertilizers industries produce gypsum. Hazardous waste such as inflammables, composite explosives, or highly reactive substances are produced by industries dealing in metals, chemicals, drugs, pharmaceuticals, dyes, pesticides, rubber, goods, etc. The disposal of non-biodegradable industrial solid waste, if not done by a proper and suitable method, may cause serious threat to the environment. New innovations have led to different use of waste material nowadays. Fly ash and slag from the steel industry are utilized by the cement industry. Large quantities of toxic waste are usually destroyed by controlled incineration, whereas small quantities are burnt along with factory garbage in open bins. Moreover, solid waste, if not managed effectively, affect the components of the environment. Do you know about waste recycling? Fuel obtained from plastic waste has high octane rating. It contains no lead and is known as green fuel. Due to recent developments made in chemical and textile industry, cloths will be made from recycled plastic wastes. These will be available soon in the global textile market. In India, our cities and towns face endless hours of power cut. We can also see piles of rotting garbage here and there. There is a good news that we can get rid from both these problems simultaneously. Technology has now been developed to produce electricity from the garbage. A pilot plant has been set up where, after removing ferrous metals, plastic, glass, paper, etc. from garbage, it is mixed with water. It is then cultured with bacterial species for producing methane, commonly known as biogas. The remaining product is used as manure and biogas is used to produce electricity. 14.6 Strategies to control environmental pollution. After studying air, water, soil, and industrial waste pollution in this unit, by now you must have started feeling the need of controlling environmental pollution. How can you save your immediate environment? Think of the steps, activities which you would like to undertake for controlling air, water, soil, and industrial waste pollution in your neighborhood. Here, an idea about the strategies for the management of waste is given. 14.6.1 Waste Management. Solid waste is not the only waste which you see in your household garbage box. Besides household discards, there are medical, agriculture, industrial, and mining waste. The improper disposal of waste is one of the major causes of environmental degradation. Therefore, the management of waste is of utmost importance. You must be aware of Swachh Bharat Abhiyan or Clean India Mission launched by the Government of India. Two programs are being implemented under the broad umbrella of the Swachh Bharat Abhiyan. These are Swachh Bharat Mission Urban SBMU and Swachh Bharat Mission Gramin SBMG. The SBMU primarily aims at making urban India free from open defecation and achieving 100% scientific management of solid waste in the country. The SBMG targets to bring about an empowerment in the general quality of life in rural areas by promoting cleanliness and hygiene and eliminating open defecation. It is accelerating its effort to achieve the goal of universal sanitation coverage by 2nd October 2019, which is the birth anniversary of Mahatma Gandhi. If you have participated in some event in Swachh Bharat Mission, write your experiences. Collection and disposal. Domestic waste are collected in small bins, which are then transferred to community bins by private or municipal workers. From these community bins, these are collected and carried to the disposable site. At the site, garbage is sorted out and separated into biodegradable and non-biodegradable materials. Non-biodegradable materials such as plastic, glass, metal, scraps, etc. are sent for recycling. Biodegradable waste are deposited in landfills and are converted into compost. The waste, if not collected in garbage bins, find its way into the sewers, some of it as eaten by cattle. Non-biodegradable waste like polythene bag, metal, scraps, etc. choke the sewer and cause inconvenience. Polythene bags, if swallowed by an animal, can cost their lives also. As a normal practice, therefore, all domestic waste should be properly collected and disposed. The poor management causes health problems leading to epidemics due to contamination of groundwater. It is especially hazardous for those who are in direct contact with the waste, such as rag pickers and workers involved in waste disposal, as they are the ones who handle waste material mostly without protective device such as gloves or waterproof boots and gas masks. What can you do for them? 14.7 Green Chemistry. 14.7.1 Introduction. It is well known fact that self-sufficiency in food has been achieved in India since late 20th century by using fertilizers and pesticides and exploring improved methods of farming, quality seeds, irrigation, etc. But overexploitation of soil and excessive use of fertilizers and pesticides have resulted in the deterioration of soil, water and air. The solution of this problem does not lie in stopping the process of development that has been set in, but to discover methods which would help in the reduction of deterioration of the environment. Green chemistry is a way of thinking and is about utilizing the existing knowledge and the principle of chemistry and other sciences to reduce the adverse impact on environment. Green chemistry is a production process that would bring about minimum pollution or deterioration to the environment. The byproducts generated during a process, if not used gainfully, add to the environmental pollution. Such as processes are known not only environmental unfriendly but also cost ineffective. The waste generation and its disposal both are economically unsound. Utilization of existing knowledge base for reducing the chemical. Nobel goes to green chemist Yes Chauvin, Robert H. Grubbs, and Richard R. Sherrock. Yves Chauvin, Institut Français du Pétrole and Ruelle Mammalian, France. Robert H. Grubbs, California Institute of Technology, Caltech, Pasadena, CA, USA. And Richard R. Sherrock, Massachusetts Institute of Technology, Cambridge, MA, USA, won the 2005 Nobel Prize in Chemistry for work that reduced hazardous waste in creating new chemicals. The trio won the award for their development of the metathesis method in organic synthesis, a way to rearrange groups of atoms within the molecules that the Royal Swedish Academy of Sciences likened to a dance in which couples change partners. The metathesis has tremendous commercial potential in the pharmaceuticals, biotechnology, and foodstuffs production industry. It is also used in the development of revolutionary, environmentally friendlier polymers. This represents a great step forward for green chemistry, reducing potentially hazardous waste through smarter production. Metathesis is an example of how important application of basic science is for the benefit of man, society, and the environment. Hazards along with the development activities is the foundation of green chemistry. Have you perceived the idea of green chemistry? It is well known that organic solvents such as benzene, toluene, carbon tetrachloride, etc. are highly toxic. One should be careful while using them. As you know, a chemical reaction involves reactants attacking reagents and the medium in which the reaction takes place. Extent of any reaction depends upon physical parameters like temperature, pressure, and use of catalyst. In a chemical reaction, if reactants are fully converted into useful environment-friendly products by using an environment-friendly medium, then there would be no chemical pollutants introduced in the environment. During a synthesis, care must be taken to choose starting materials that can be converted into end product with yield approximately up to 100%. This can be achieved by arriving at optimum condition of synthesis. It may be worthwhile to carry out synthetic reactions in aqueous medium since water has high specific heat and low volatility. Water is cost-effective, non-inflammable, and devoid of any carcinogenic effects. 14.7.2 Green Chemistry in Day-to-Day Life. Number 1. Dry cleaning of cloths. Tetrachloroethane CCl2 double bond CCl2 was earlier used as solvent for dry cleaning. The compound contaminates the groundwater and is also suspected carcinogen. The process using this compound is now being replaced by a process where liquefied carbon dioxide with a suitable detergent is used. Replacement of halogenated solvent by liquid CO2 will result in less harm to the groundwater. These days, hydrogen peroxide is used for the purpose of bleaching clothes in the process of laundry, which gives better results and makes a use of lesser amount of water. Number 2. Bleaching of paper. Chlorine gas was used earlier for bleaching paper. These days, hydrogen peroxide H2O2 with suitable catalyst which promotes the bleaching action of hydrogen peroxide is used. Number 3. Synthesis of chemicals. Ethanol is now commercially prepared by one-step oxidation of ethene in the presence of ionic catalyst in aqueous medium with a yield of 90%. CH2 double bond CH2 plus O2 in the presence of catalyst PD and Cu in water forms CH3CHO 90%. 4th, green solution to clean turbid water. Powder of kernel of tamarind seeds has been found to be an effective material to make municipal and industrial wastewater clean. It is non-toxic, biodegradable, and cost-effective material. This powder is usually discarded as agricultural waste. The present practice is to use alum to treat such water. It has been found that alum increases toxic ions in treated water and can cause diseases. Green chemistry in a nutshell is a cost-effective approach which involves reduction in material, energy consumption, and waste generation. Think it over. What is our responsibility as a human being to protect our environment? Some concepts, if followed by an individual, contribute towards a better quality of our environment and human life. Always set up a compost tin in your garden or any other place in your home and use it to produce manure for your plants to reduce the use of fertilizers. Use of cloth bag and avoid asking for plastic carry bags when you buy groceries, vegetables, or any other item. See that all newspaper, glass, aluminium, and other items in your area are recycled. We might have to take little trouble to locate such dealers. We must realize that we do not have solution for every problem, but we can concentrate on issues which we feel strongly about, can do something about. We should take care to put into practice whatever we preach. Always remember, environment protection begins with us. Summary, finally. Environmental chemistry plays a major role in environment. Chemical species present in the environment are either naturally occurring or generated by human activities. Environmental pollution is the effect of undesirable changes in the surrounding that have harmful effects on plants, animals, and human beings. Pollutants exist in all the three states of matter. We have discussed only those pollutants which are due to human activities and can be controlled. Atmospheric pollution is generally studied as trophospheric and stratospheric pollution. Troposphere is the lowest region of the atmosphere in which man along with other organisms including plants exist, whereas stratosphere extends above troposphere up to 50 km above sea level. Ozone layer is one of the most important constituents of stratosphere. Trophospheric pollution is basically due to various oxides of sulfur, nitrogen, carbon, halogens, and also due to particulate pollutants. The gaseous pollutants come down to the earth in the form of acid rain. 75% of the solar energy reaching earth is absorbed by the earth's surface and rest is radiated back to the atmosphere. These gases mentioned above trap the heat which results into the global warming. It is important to realize that these very gases are also responsible for the life on the earth as they trap the requisite amount of solar energy for the sustenance of life. The increase in the greenhouse gases is raising the temperature of the Earth's atmosphere, which, if not checked, may eventually result in melting of polar ice caps and consequently may submerge the coastal landmass. Many human activities are producing chemicals which are responsible for the depletion of ozone layer in the stratosphere, leading to formation of ozone hole. Through the ozone hole, ultraviolet radiation can penetrate into Earth's atmosphere, causing mutation of genes. Water is the elixir of life, but the same water, if polluted by pathogen, organic waste, toxic heavy metals, pesticides, etc., will turn into poison. Therefore, one should take care to follow international standards to maintain purity levels of drinking water. Industrial waste and excessive use of pesticides results into pollution of land mass and water bodies. Judicious use of chemicals required for agriculture practices can lead to sustainable development. Strategies for controlling environmental pollution can be: number 1, waste management, that is reduction of waste and proper disposal, also recycling of material and energy. Number 2, adopting methods in day-to-day life which results in the reduction of the environmental pollution. The second method in a new branch of chemistry which is in its infancy known as green chemistry. It utilizes the existing knowledge and practices so as to bring about reduction in the production of pollutants. Chapter done, my dear students. Share your views, how it was, and if it helps you, then please like it and also share with your friends so that they will also get the benefit from these audiobooks. Thank you so much.